Day 247 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. You already know what it is, and this time we're at day 247, still going strong, y'all. Today we have question number 133, clone graph. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand, so let's get into it. Question says, given the reference of a node in a connected undirected graph, return a deep copy clone of the graph. Each node in the graph contains the value, which will be an integer in the list of nodes of its neighbors. So each graph will contain a node. This will be its value right here, and this will be the list of neighbors that the node is being connected to. The For simplicity, each node's value is the same as the node's index, one index. For example, the first node with the value equal to 1, the second node with the value equal to 2, and so on. The graph is represented in the test case using an adjacency list. An adjacency list is a collection of unordered lists used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. The given node will always be the first node with a value of 1. You must return a copy of the given node as a reference to the clone graph. So, let's break that down. It's a lot to take in, but let's break it down by looking at example 1, right? Now, the first thing we need to do when looking at example 1 is we need to understand what is a deep copy. So, a deep copy refers to the process of creating a new copy of an object where all of the elements or objects within are recursively copied as well. This ensures that the copied object is entirely independent of the original, meaning changes to the original object do not affect the copy and vice versa, right? So that's what a deep copy is. We need to create a copy or a clone of the graph that they give us so that when we uh, change or modify modify the clone or modify the original, it does not have effect on the either or, right? So if we modify the clone, it won't affect the original, and if we modify the original, it won't affect the clone. That's the purpose of a deep copy, right? So now let's see what else. Let's look at example 1 so we can see what it is exactly that they want us to do. So in example 1, we have this is the original graph right here. We can't return the same graph because if we return the same graph, then when we modify this graph, it'll also modify this graph, which is not what we want. Now, this graph down here is close. However, the nodes were cloned, but the graph is messed up, doesn't have the same connection. So as you can see in this graph down here, 1 has a neighbor of 3 and 4, whereas up here 1 has a neighbor of 2 and 4, right? So this isn't right as well. This is the correct graph that we are looking for right here. This looks like the clone. The nodes are new. The graph looks the same, right? So these have new nodes. However, they are connected the same way, or 1 has the same neighbors. 1 has a neighbor of 2 and has a neighbor of 4, just like it does in the original graph, where it has a neighbor of 2. 1 has a neighbor of 2 and has a neighbor of 4 as well. So let's go through the input and output just so we can make it make sense a little bit more. So in this case, we have the input is the adjacent list or the edge list. I think that stands for adjacency. Or yes, excuse me, the adjacency list equals a 2D array. First array is 2, 4. Second array is 1, 3. Third array is 2, 4, and the last array is 1, 3. The output is the same to the array. First array is 2, 4. Second array is 1, 3. Third array is 2, 4, and the last array is 1, 3. So as you can see, this adjacency list is the list of the neighbors of each node that we're looking for. So it says up here that that each node's value is the same as the node's index in a one index array. For example, the first node will have a value equal to 1 and the second node will have a value equal to 2. So this right here is the adjacency list of its neighbors. So this will be the first node. This has neighbors, first node being which will have a value of 1. 1 has a neighbor of 2 and a neighbor of 4, right? Then this will be the second node value right here. Value 2 has a neighbor of 1 and a neighbor of 3. Then this would be the third node. The third node has a neighbor of 2. This is the third node right here, has a neighbor of 2 and a neighbor of 4. And this would be the fourth node right here, and the fourth node has a neighbor of 1 and a neighbor of 3, just like it does in the clone graph, right? So this would be the original, this would be this graph, this output would be the clone graph, and this would be this graph, right? And it says the same thing right here in the explanation. There are 4 nodes in the graph. First node has a value 1, its neighbors are the second node, which is a value of 2, and the fourth node, value of 3, second node, and so on, just like I showed y'all. So let's look at example 2 and 3 in case they try to throw some trick questions our way. So in example 2, we have the adjacency list equals a 2D array. The output is still 2D array. The explanation says, note that the input contains one empty list. The graph consists of only one node with a value of 1, and it does not have any neighbors. So that's why we still return a 2D array, because that would mean the graph would have one node, which would be a value 1, but it will have no neighbors. So let's look at example 2, where it's just an empty graph. So remember, this one has one node, where this one has 0 nodes, right? So in example 3, we have the adjacency list is just a blank array. The output is a blank array as well, and the explanation says this is an empty graph. It does not have any nodes. So now that we understand the question, y'all, let's get into the fun part, the actual solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. Then after you do that, don't forget to like, comment, and subscribe, y'all. Bring your mouse right over here, click that subscribe button for me. Now, let's get into the solution, y'all. So first thing we need to do in the solution is we're going to create a dictionary, which is going to store the clone nodes and the original nodes, right? So first we're going to do that by saying var declare variable. We're going to call it cache, colon, open up the square brackets. It's going to be a node. It's going to have a node. The key is going to be a node. The value is going to be a node. And we are going to initialize it like that with a blank dictionary, right? So once again, this node right here, that's going to hold the original node, which is the value, and then the key is going to hold the clone node, right? So now let's get into the actual function. So the first thing we need to do is we need to check if the input node is nil, and if we are going to return nil if it is, right? So we're just going to say guard let node equal node, else, open up brackets, return nil. Then we're going to come down here. Now we need to check if the current node has already been cloned and return the cache node if it has, right? So now we're going to say guard cache, open the square brackets, node. Then we're going to come outside of that, say equals nil, else we're just going to open up the brackets. I'm going to say return cache square brackets node. Then we're not done yet. We're just going to start. And now we need to create a new node with the same value as the original node. So remember, it's a deep copy, so we need to create a new node, right? But it needs to have the same value as the original node. So in order to do that, we're just going to declare a variable called cloned, and we are going to set that equal to node, open up the parentheses, node.val. So that's how we are going to create the new node with the same value. It's going to be stored in this cloned right here. Now we need to store the clone node in the cache so we can avoid duplicating work, right? So we can avoid duplications, we need to store the clone node. So we're just going to say cache square brackets node, come outside the square brackets, and set that equal to cloned. Now we need to recursively clone the neighbors of the current node. We're going to use a map to create an array of the clone neighbors, right? So to do that, we're just going to say cloned dot neighbors, clone dot neighbors equals node dot neighbors, excuse me, should be an S after this too, my bad. We are going to say dot map, open up the parentheses, open up the brackets, we're going to say clone graph, open up the parentheses, $0, and now this $0 represents each node that we're going to iterate through. Now all we have to do is return the clone node, right? So in order to do that, we just come down here and say return clone. Now that should be all she wrote, y'all. I told y'all it wouldn't be that difficult. The problem looked way harder than it actually is. Let's run it, see how it runs. Okay, we got a typo. Cannot find cached in scope. It should be just cached, not cached. Sorry about that, y'all. Let's see. And it's accepted, y'all. So let's submit it. Make sure it stays accepted after we submit it. Let's see, y'all. Let's see. Ooh, 4 milliseconds beats 90.94% of users with Swift, y'all. Those some good numbers right there. Those we could work with that. That's something we could work with right there. And this was a simple, easy solution that I feel like everybody could understand, y'all. We're just cloning each node and mapping them using a hash map. This is the original node, and this is the clone node. We're using a hash map to keep track of the nodes, and that's how we're creating a deep copy of the graph, y'all. So I hope y'all learned something today. I hope to see y'all here tomorrow for another day, another LeetCode problem, y'all. See y'all then.